Hello Slackware ARM community. I'm Stuart Winter, the platform architect and developer for Slackware on the ARM platform. Now in this episode, I'm going to walk you through the process of migrating the operating system and your user data, so usually your data that lives in /home, onto, well, from its existing storage, in my case it's an SSD, onto another piece of storage. In my case it's going to be a spinning SATA drive. Because what happened the other day was my home gateway that runs on an Orange Pi Plus 2E runs Slackware ARM 15.0, so 32-bit. For a while, maybe a few weeks, it's been having a few issues appear in the system log about related to the storage. So I thought it was high time to replace that storage, so at least try and work through what the issue might be. I don't know if the issue is about the hard drive or SSD itself, although I don't think so. I'll show you why in a minute. It could be related to the USB to SATA converter, although I have the same one on other machines and it works fine. It could also be the USB port of the Orange Pi Plus 2E itself, or maybe the board, I don't know. But because it had been happening now for a few weeks, I've decided to take the step and migrate everything off onto a new hard drive and then see how that goes. And I thought to myself, even though I've done it a couple of days ago, I thought I'd show you how to do it, because it is quite a useful thing to be able to do, and it's actually quite easy to do it. So that's what we're going to do in this video. Now before we get into it, I just wanted to say thank you again for your donations and support to the project, because it does cost money to run this stuff. And yet again, this piece of hardware, which was my main switch into which all of the build machines and related services are connected, including my office itself, this has now gone to silicon heaven because the fan died in it. It's very old. This is probably, I don't know, 18 years, no, 15 years old, something like that. I don't know. It's pretty old, and the fan died and it cooked itself. So, which is quite interesting actually, because it continued to function on some of the ports. So I guess some of the ASICs were completely toasted. So it continued running for a while, and I was pretty confused as to why parts of the network were unreachable and others weren't. But then I power cycled it and it wouldn't boot back up again, so it's completely toast. And I've now had to order another one. So thanks a lot to you guys, because I've been able to keep the project going again by replacing yet more absolutely ancient hardware. And actually I was thinking what to do with it, because I thought it's quite a nice little box and it's rack mountable, although I don't have a rack here. I have the ears for it, or the mounting clips I mean. But I thought perhaps I could put some ARM hardware in it, because it does have, it's got obviously a position for a fan at the back there, but I'm not sure yet. I don't know what I'll do with it, but anyway, it's completely toast as a network device. All right, without any further ado, let's get into it. Alright, so we're going to be doing this on my Pinebook Pro, so let's just open that. There we go. Oh, need to clean the screen here, don't I? I might do that whilst it's booting up. There. Hopefully that's better for you. Okay, so now that's booted up. Okay, so we have a few things that we need to connect up here. So this is the Orange Pi Plus 2E. This is its storage here. And this is the power supply for the storage. So this power supply actually connects to the the USB to SATA adapter. So I always recommend, if you can, that you use a powered version of these, although if you can see the one at the back there, that one here is connected to the Rock Pro 64, and that's not that doesn't have an external power supply. It's powered from the USB port and it works fine, but again, I always recommend having external power, because my experience on ARM is that usually the adapters, they just break over time, and generally it's best to try and avoid stressing the main board through providing power to external devices if you can. But anyway, yeah, so we need to plug this in. So first of all, I'm just going to plug that into the power at the back, so we get the drive powered up. Yeah, the light's on. Then what we need to do is I'm going to connect up the basically the serial cable for it. So you can see it's here, plugged into the serial ports, and plug that into the into my Pinebook Pro. And if I log in now, oh, actually I could have logged in as my as myself, but it's probably in the command history, isn't it? Dmessage, yeah. Okay, so you can see that the serial adapter here has been recognized as TTY USB 0. Okay, and what we're going to do now is start KDE, because then that way I can record the screen really easily. So we'll start up KDE now. Now we're in KDE. I've opened up a few tabs. So the Pinebook Pro, I am using the docking station. Brent got me onto this. Can't really show you that, can I? So the docking station is here at the back. So this is what I have for my Pinebook Pro. Brent actually suggested this when we first started, or rather when he started the work to get this hardware model supported, and it's really useful because it has Ethernet and it has additional USB 3 ports as well. What we're going to do here is, hopefully I've got an Ethernet address, or rather an IP address, and oh yeah, let's become root. Okay, yeah, cool. So what I'm going to do is I'm going to mount I'm going to mount my NFS server, which has all of the Slackware stuff on it. So HD devels ARM Slack console scripts. Now I have a number of scripts that have all of the settings for the different hardware models. I suppose I could put these online. Let me know in the comments if you're interested in them. Although this stuff is documented in the Slackware AArch64 installation guide, so you shouldn't really need it. But if you're interested, let me know in the comments and I can just put them on the FTP site after I clean them up a little bit. We're going to use Screen here to access the serial console of the Orange Pi Plus 2E, because it's really convenient and I like Screen. And it has a log file for it if you want to look at the log. I don't in this instance, but it is useful sometimes. And it's going to set the sort of behavior of the screen. And then lastly, there is the device to which the serial cable is connected. And these are the settings for accessing the serial port on the Orange Pi Plus 2E. Okay, so what we're going to do is we are going to run that script, Orange Pi Plus 2E, and at the moment there's nothing on the screen because the Orange Pi is not actually plugged in. So I've got the Ethernet plugged in, I've got the, oh, is that in properly? Yeah, it is. Okay, so that's we've got connected via USB, we've got the SSD drive plugged into a USB to SATA adapter, we've got Ethernet, we've got the serial cable. The only thing we need to do now, I think, is just plug it into the power. So if I just grab that. Actually, funny enough, I don't know what this, I'm just going to show you. I was thinking I could plug this into my European extension cable, but of course this isn't an EU connector. I don't know what that is. I assume it's a US one, because some of this stuff got shipped over from the US years ago. I don't really know what that is, but plug it into these travel adapters. Although really, you shouldn't use a travel adapter for for powering things long term. Although, to be honest, I've been powering it long term for about like 6 years. it was fine. And it's not as if it draws much current, is it? But anyway, it is what it is. Right, let's plug that in. Ooh, there we go. And hopefully we should see something on the screen in a moment. Yeah. All right, so we're now looking at the U-boot bootloader on the Orange Pi Plus 2E. It's going to reset the serial bus a couple of times because of legacy reasons. I used to have issues on this old ARM stuff with spinning hard drives and USB caddies and things like that. So I found that just making the bootloader restart the USB bus a couple of times works around that problem. But with an SSD drive, you certainly don't need to do that. Okay, so the system is booting. It won't take too long. So here we go. Anybody know any jokes? Put them in the comments and I'll use them next time I have to wait for the system to boot. As long as they're clean. All right. So the system has booted and we are logged in as a root. Now, I'm going to log in though, if I remember what the IP is of this thing. Oh yeah, there it is. So what I'm going to do is I'm going to log in as root though, remotely, because we're running under screen, it has a different window size and it makes things a little bit more tricky. It's easier to log in remotely, but when we want to watch the system boot, it's really useful to use the serial cable, and we'll also use it later as well. But at the moment, I'm just going to log in remotely. So let's get root on this. Okay, so let's check about the hard drive. I think it's -A, but let's just check. -all, yeah. So that prints all the information. So it should be SDA. Yeah, SDA is where the operating system and the data is stored. As you can see, it's 223 gigs SSD. This stuff here, the dev MMC block, that is the SD card on which the U-boot bootloader lives. The SD card is used to contain the U-boot bootloader, and also it has a separate partition on it to contain the U-boot config as well. But it's not, the SD card in Slackware ARM 32-bit is not used in the same way as it is for ARCH64. Before I stopped development of 32-bit ARM, I was planning on migrating the ARM 32-bit stuff to the same, use the same design as ARCH64, but of course I never did that. So so let's have a look. Smart CTL-A/SDA less. So you can see it's a Kingston SSD. Overall health is good. Look, it passed. Blah blah blah. No errors logged. Yeah, I don't think that it's an issue with the SSD drive. It's probably either an issue with the USB to SATA adapter, or it's a problem with the board, maybe the USB port itself, or perhaps the board. I don't know, to be honest. Okay, so we've looked at that. Now, what we need to do is I need to begin copying the data off of the SSD onto my target drive. So this is the target drive. This is a USB. Again, this is actually a spinning hard drive inside of a USB caddy. It's quite cool actually because it disconnects from the base. You can pull that off. But yeah, so this is from an old build machine called Zippy, which was the master. It still is actually, but now Zippy has an SSD on it. But this has been working for years, and as far as I know, it's in good condition. So I'm going to use this one. So we just need to power this up. Hopefully I've got some space left on the power strip, which I think just one. When these spinning drives are no more, I'm going to miss that spinning noise. You know, that noise as the heads lift up, and that clicking sound as a drive sort of initializes. I'm going to miss all of that stuff, I'll tell you. All right, so what we're going to do now is we just need to get now the driver's powered up, we just need to plug it into, oh, not that port, because that's used for the That's the USB 2 port on the Pinebook Pro, and that's what we're using for the serial console. So we will plug that into the back, which into the back of the docking station, which is USB 3. Here we go. Look, you can hear it clicking. You can hear it spinning up again. Oh, maybe you couldn't. I don't know. Right. Okay. So hopefully we should have the external hard drive registered. Oh, I think I must have knocked something when I plugged that in. So let's make sure I've still got the... yeah, I do. Good. Okay. So -L, do we have it? SDA, yeah, we do. So on the Pinebook Pro, which is what we're using here, it uses NVMe. So the local storage is on NVMe. Oh, sorry, what am I talking about? I'm looking here at, this is Lobster. This is the Orange Pi Plus 2E. What am I talking about? That's through, yeah. Goodness me. Right. Whizbit is the name of my Pinebook Pro. Right. So demessage tail. So I didn't knock anything. Everything was fine. Okay. So SDA. Okay. So now that that disk is installed, connected to the USB bus on my Pinebook Pro, we can see that it's come up as SDA. So on the Pinebook Pro, we use NVMe, as you can see at the top here. So the root file system, the operating system, and everything else is on NVMe. So it's not SDA on this one. As you can see, SDA here is this GoFlex disk, which is the black caddy that I showed you. Okay, so as you see, we've already got a couple of partitions on this drive because it's been used as a build machine. So I'm just going to wipe out the partition table. 0f equals /dev/SDA block size, I don't know, 1m count equals 3. That'll clear it off. I think that's right, isn't it? FDA. That'll do. So all I'm doing here is clearing off the partition table. The partition tables are not 3 megabytes in size, but I can't remember what. Oh, so I guess it's, yeah, probably I could have done with 512 bytes anyway. It doesn't matter. It's done now. Right. So we need to see what the layout is on Lobster. Okay. So the first thing to do is to have a look at the FS tab, and you'll see that as in Slackware, since the release of Slackware 15 or Slackware ARM 15, we use disk labels. So the Slackware installer creates disk labels for the swap partition and the root file system. It does not handle, and I can't imagine I'll ever make it handle either, any other mount point. But on the target drive, what we need to do is replicate the same partition layout. So we've got Linux swap partitions, the first, then we've got Linux, which is where the OS lives, and then SDA3 is /home, as you can see up here. So this is on the Orange Pi Plus 2E, which is the machine that we need to copy the data from. So back on my Pinebook Pro, we will create ourselves some partitions. Okay, so the first one is Linux swap, and we've got that as 3 gigs. That's more than we need. So N partition 1, first sector 3. I'll just replicate it. Change the type to 82. Linux swap. Next partition is going to be for whatever first sector. I think how much disk space is that? 80 gig. Oh, what do we have? Yeah, that's fine. So let's just put plus 80G, and then change that to bootable. And finally, everything else will be the home partition. So swap partition, partition 1, OS partition, partition 2, and the home or data partition is partition number 3. Let's write that to the disk. Okay, now what we need to do is we need to create the file systems in the swap partition. So Now I need to remember what the format is for this actually, so -L. Okay, so we're going to create the swap partition on SDA1. Now we need to use the same labels, so SLK swap 0, I'll just type that in actually, SLK swap 0 /dev/SDA1. Okay, and then SDA2 is going to be SLK root, like that, I believe. I should know, I designed all this stuff. Okay, MKFS.ext4, I think that's right, isn't it? Yeah, SLK root, SDA2, oh, what am I doing? That is not how you do that. There's probably, because I'm using the same command syntax as for MK swaps, it's not the same. What is the label? Volume label. Oh, it is actually the same parameters. I just deleted the -L. There we go. You can also label these things later with E2 label as well for the ext4 file system. Okay, so that's for SLK root, and that's fine. And then finally, we need to, I'm not going to put a partition, a label, file system label on the last one. This one will take slightly longer. Okay, so I've created the partition layout. I have labeled the swap partition and the root partition where the OS lives. I've labeled those with the sort of standard Slackware ARM naming scheme, which also is the same as what is expected in the operating system's FS tab. And SDA3 is /home, but that doesn't need to be labeled, so we won't do that. All right, so what we need to do now is I'm going to create a munt/lobster, because that's the name of the home. Yeah, that should be fine. I've just created two directories in /mnt on my Pinebook Pro, so I can mount the target drive on which we'll copy the data, or rather onto which we'll copy the data. So let's do SDA2 /munt/lobster OS. Lobster is the name of the the Orange Pi Plus 2e. That's the name of that's the host name of it, in case you're wondering. So then SDA3 lobster home, and here we go. So they are now mounted. Okay. Then exports. Cool. What I'm going to do now is I'm going to NFS export the these two paths on my system. So so I can NFS mount them on Lobster and then copy the data over the network. So what I'm going to do here on my build machine is just copy the syntax. So I've got an exports, etc. exports file ready to go. So I can't remember what the syntax is and I don't want to look at the man page. So I can just copy what already works. And that's Lobster. Okay, let's paste that into here. And what I'm going to do is /mnt/ well, actually I don't need the root file system. So lobster OS and then do the lobster home like that. Then I'm going to start on my machine rc.rpc rc.rpc restart like that. So I'm going to, this is, RPC is the port mapper. It's what handles, you need it for NFS, let's say that. Now I'm going to restart NFS, or start NFS. Actually, well, NFS, I'm not going to restart NFS because it's not actually started. I don't usually run NFS on my client machines. And then I'm going to export fs/va to actually export those exports. Awesome. And now if I do show mount-e localhost, should show me these two are exported. Okay, so on Lobster, the Orange Pi Plus 2e, I've created two directories, /p/os and /p/home, and these are going to be the mount points into which I'll mount the target drive that's exported from the Pinebook Pro over NFS. So now I'm going to actually do the NFS mounting. And so I'm mounting Whizbit, which is the Pinebook Pro. I'm mounting /MNT/LobsterOS, which is where /dev/SDA2 on the Pinebook Pro is mounted. And I'm going to mount that into /P/OS. But what's happened here is that the remote procedure call service wasn't started, and we need that for file locking, otherwise things are going to get messy. So I've just started RPC there, and now I can mount both of the mount points. As you can see, we now have them both mounted. At the bottom there we've got Whizbit, we've got LobsterOS and Lobster Home mounted as /P/OS and /P/Home respectively. And you can see the sizes available there, which is what we expect. The way I do this is to use a shell script, because we're going to be doing this in 2 passes. The first is when the machine is up and running with the processes running, and secondly we'll shut the processes down, we'll put the server into run level 1. So I'm just using rsync to copy the home directory, and then the operating system components directories like bin, boot, dev, etc. The only thing I'm not copying is the sys and proc directories, because those are reserved for the kernel. The kernel populates those. So the only thing we need to do on the target file system is just create the directories so they exist and the kernel can mount them. Okay, so it's now time to run that shell script and kick off the copy process. This will take a few hours to copy, so we'll come back in a bit. Okay, so the copy process has completed, and we can see, yeah, there we go, 20 gigs of the root partition is now copied to the remote file system, and likewise for /home you can see 5.6 gigs and 5.6 gigs. All right, so TCY, yeah, oh, so this is the SSH login. So what we need to do now is switch to the serial console, which is, where is that? Is it that one? Oh yeah, there we go. Okay, so this is the serial console, and we need this because we're going to now put the server, the Lobster, the Orange Pi plus 2E, into the run level number 1. Because at the moment, whilst we have copied all of the data, the thing is that because the operating system is running, it's quite possible that some of the files that we've copied have subsequently changed. So things like log files, just or files that users have created, that kind of thing. In this instance, there's nothing that users created because it's only me that would have been using it at the moment. But nonetheless, we need to stop all of the processes running, or as many as possible that are writing to the file system, and then recopy it. So what we've done initially with the first pass is just to, it allows us to copy the data whilst the operating system is still serving its purpose, is still functioning on the network as a server. So what we're going to do now is switch to run level tel init, I think it is, isn't it? Tel init 1, I think, should be right. And that should switch to run level 1. Oh, there we go, yeah. It's probably outputting on. Ah, of course it's switched that down, okay. Okay, so it's switched to run level 1. So I need to log in again, if I can type in the password correctly. Could have a problem with the key map here. Oh no, there we go. Okay. Right, so we should see run level. We should be at run level 1. Okay. Yeah, so we're now at run level 1. So number 3 was the previous run level, but we're now at run level 1. So the question is though, because I think normally this brings the networking down. Yeah, it does. But there we go. Okay. So yeah, it's unmounted. When we switched run levels, it's unmounted everything that we'd mounted. So what I'm going to have to do, I don't actually know if that will work because I haven't done this for quite a long time. when I did it myself a few days ago, I actually removed the hard drive and connected it onto a different machine and then just resynced it locally and then booted it back up. But in this instance, I don't want to do that actually. I'm just going to do it like this. Let's see if RPC, grep RPC. Yeah, okay. Mount, let's see if that still works. No, it's shut down RPC. Okay. So shrc.drc restart. See if that works. Yeah, it does. Great. And perhaps actually whiz-bit. Perfect. Okay, cool. So we're in run level 1. We shouldn't really have much open in the way of files, apart from libraries and stuff, but there shouldn't be much. No, that's fine. We don't care about our var run. That's all right. And /home, definitely won't be anything in /home. I think that's pretty much it, really, because the only thing on this machine really that's going to change is things in var log and /home, pretty much. So then we run the copy again. Now I just realized that I forgot to show you the error log in the system. So I saved it, and here you go. This is what it looks like. As you can see, yeah, so it happened in May, on the 28th, and then again on June the 1st. And actually, because I have this system configured to reboot itself automatically in the event of a kernel panic, the system actually rebooted itself, and I came back to wonder why there was 0 days uptime, and that was why. So yeah, I saved this for you so you could see, but again, yeah, I really do at this point. I think it's a problem with the USB to SATA cable. But we'll see once the new system's been running for a few weeks or so. All right, so the second copy operation from run level 1, where the processes weren't running, has completed. And again, you can see that we've got everything. Well, at least the sizes match. But yeah, so that's done. So what we're going to do now is we need to U-mount the targets, OS, is lobster, yeah, and then U-mount home. There should be nothing else. Just make sure it's all unmounted. Just get rid of that directory. We don't need that anymore. Okay, so lobster is the orange pi plus 2e. So that's all good. We can now power this down. We are logged in as TC serial, yeah. So if we power this, I think that's right, isn't it? Sure. Should be good. Yeah, I think so. Right, so power that off. Because it's ARM, we don't need, there's no bootloader that we need to write to the target drive in the master boot record or anything like that. It doesn't work like that in ARM. We just need to literally copy everything and should be good. Although, yeah, let's power that off. Okay, so lobster is going down. There we go. It's powering itself off, shutting everything down. Okay, cool. System halted. Right. So what's next is that whiz-bit. Right. So I'm going to U-mount. So whiz-bit is the Pinebook Pro. Lobster home. Okay, and so, right, that's busy because I think we need to stop exporting it. Actually, I suppose we could just do this. Just kill that off. Yeah, there we go. Just, yeah, so the reason it wouldn't let me U-mount it was because the NFS server had it open because it was shared via the /etc/exports file. So we can now, we've done that. Right, the only thing I'm going to do, lobster OS, is just change udev, well, it shouldn't, need to do that. No, that's fine actually. I was just going to check the UDEV rules, but I don't need to because I haven't changed the chassis. So I haven't changed the actual... Oh, there's nothing in there anyway. Okay, there we go. So yeah, I don't need to do anything. So I was just... The only thing I was interested there was in case the Ethernet port, or the MAC address of the Ethernet port was hard configured to be ETH0. But of course, I actually haven't changed the machine in this case, so nothing has changed. It's literally just the OS going to be on a different bit of storage. So I don't need to do anything to do with that. Lobster OS. Oops, if I can do it right. Yep, and then sync to synchronize all the data, and we are done. Cool. Okay, so there we go, system halted. And what we need to do now is disconnect the hard drive from the Orange Pi Plus 2E, well, the SSD, and connect the spinning hard drive instead. So what we need to do is, now that the system is shut down, I need to exchange the hard drives basically. So come over and let's see that. Okay, so the system is halted, so that's good, but I'm going to unpower the... God, it's quite stiff. So I've unpowered the board. There's no power to the board anymore. So I'm going to disconnect the USB port from the USB port there, and then also, there it is, unplug the power for it as well. So now the old SSD drive and its USB caddy. Right, that's done. Right, now let's take this hard drive carefully, because it's still powered up, and move that there. So now I just need to disconnect the USB cable from the Pinebook Pro and connect it. And now I need to connect it to the USB port of the Orange Pi Plus 2E, like this. And then finally, we just need to connect the power back to the Orange Pi Plus 2E, and we should see, we hope, should all connect, yeah, still powered up. Should be good. So you put the power in, and then if you look now at the screen, it is booting again.
Yay.
So hopefully it'll find the kernel, well, hopefully it'll detect the, the drive first. You see, 0 storage devices found. Yeah, that's one of the reasons why we do a rescan.
There's mosquito.
1 storage device found. Okay, and yes, this is the reason why I said earlier that in the old days I've made the bootloader rescan the SCSI bus, or rather rescan the USB bus, because of things like that, where on the first pass it wouldn't find the drive in USB caddies because the drive hadn't spun up yet. So doing a second scan made it work. So yeah, that was a prime example of why I did that. This whole project has been going for over 20 years at this point, and there's so much history baked into it, with all these little nuances that I've had to cater for throughout the years. And you can see it has now booted up. Go back.
Yay.
All right, so that's been a success. I've copied the operating system from a live running machine to a target drive. I have also copied the home, or the local data that was on the storage there. And then, so I've done that in the first pass, and then I've shut it down into, or rather I've transitioned the OS into run level 1, where there's basically, there's really not much running, to avoid updating some of the files on the storage. And then I've recopied everything again and disconnected everything, put the new hard drive onto it and booted it up, and it's done. The machine is booted, it's ready to go back into service. Okay, well, I hope you found that instructive or perhaps useful. So if you like the project, you can like the video, subscribe to the channel if you wish, and also please donate to the project to help pay for things like replace the network switch and the hardware and pay for the electricity and all of that kind of stuff. It's really appreciated, and it's what allows the project to move forwards. The links are on the screen if you want to donate. So thanks a lot, and I'll see you in the next episode. Until next time, bye.